Myself Lakshya Khurana, my roll number is 9305, and this problem statement is like I will be having a given face image of which is a cropped image, and I have to identify the nose tip from the image. And this is a research paper that I am using. This research.
So input is 3D face?
Yes.
3D face for the nose tip is very simple. You take the Z information, highest the value of Z, it is the nose.
No, but there are some errors. The hair or the eyebrows. This sometimes.
But you told that cropped image. That is the thing you told that you got a cropped image. So why to keep once you are cropping, you crop your here and other thing.
Yeah. Initially I read about the 3D images and I haven't taken
3D
details.
images. 3D images challenge nahi hai. What is the challenge in that? I am not getting. See, in the 3D images, the Z value of nose, Z value of face is
Sometimes the eyebrows. Some people have.
In a case there, can you show me a case here? Either random sample is here. Whose eyebrows is this? Nose tip will be the highest. Pick. That means Z value will be the highest. Am I right or not? You tell. 3D image does not have much problem.
So this research paper is written on the. This research paper is written on the 3D images itself. The detecting the nose tip.
Who has done what I did? What I want to tell that nose tip or 3D image, if I have the frontal image or whatever it is, if I once I rotate with 3D image में तो कोई problem नहीं है, rotate करो and wherever you get the maximum Z value, that is the nose tip. Am I right? Yes or no?
This is not. I'm not able to find the cases when it is not true, but I don't think.
No, if I have the maximum, I will rotate it with 3D face. No, you have bring down the x-axis for y, z-axis for etc. Set for what is the problem? Because 3D data you have. All angle 3D data में तो तुम, right? Do you have the data?
Yeah, I don't have the data right.
But data भी कहाँ मिलेगा तुमको? Test करने के लिए. Who will give you the data? Are you going to create the data? Well, I don't have 3D camera. What I can give you, I can give you the 2 camera or more than 2. Can you create the 3D data for me? How are you going to test your system or algo?
Yeah, if I have like for every 3D image, I can have like 10 to 12 or maybe 20 2D images, and I can convert to 3D.
20 images to get a 3D image.
Maybe different layer.
Why you need to use stereo effect? You need at least 2 images, but more also you can. But let us assume that 2 or 3 scanner you take, 3 camera, 4 camera. I can give you that many. I can give you 5 camera. Rest can you create? I don't know. But now changing is illegal because of it is I can give you, if you want 5 camera, I will give you 5 camera.
I have read I can modify this for the 2D images for this data.
Are you going to do it for 2D?
Yeah, I can modify. I have read the approach for 3Ds.
Chalo, 2D done, come out 2D. You tell now.
I have read this approach only. I haven't read for any 2D. I will modify it. How I have to modify it.
That means everything is blank and you justify how you are getting the nose tip. I gave you the one example. If I have the 3D images, getting nose tip is not a problem because Z is maximum. Z value will be maximum. That is a straightforward formula.
If this would have been true, then like this research paper wouldn't have been published then.
He has done some more things, not only nose point.
He has done the nose tip detection only.
It was the large code variation and facial expression. So are you going to get that? See the word large.
The data set.
And remember one thing, while you use suppose any research paper, you have to write down in which conference you have.
Okay.
So that is easily can understand the complexity of the paper. If you can generate the 3D images, if you have, then you proceed. I can give whatever support you need, will provide. But don't ask 3D scanner, you cannot provide.
Even if sir, he can create from these 5 cameras, if you create the 3D model, then in itself it's a process. There are
Can you do it?
but you have to read about it.
Can you do it? Forget about all this. What is suggesting? That I am giving you the 5 cameras, 3 cameras, you create a 3D face.
And then use the data set on this.
No,
Nothing.
no. Just only 3-dimensional image.
प्रोजेक्शन पांच इमेज है कंबाइन करके
Each में से
Yeah.
आपको 30
Yeah, I will do that.
हाँ
I can do that. I
you
will
can do
try.
it right
Yeah.
yes and 10 or 18 students are there they will be sitting and I have the and how many camera you need now? 3
I have to read like how
5 at least.
5 cameras now I have to study something
Or camera. If you have 5 images, then you can get it.
see
There are
professor
even with the
two
also.
backside नहीं आएगा ना are you going to do it can I change it no
yeah, yes,
so what shall I write generation of
3D
3D
images
images
from 5
5 camera
2D images. Yeah.
huh? 5 today अच्छा if you want more thing what we can do we can give you but that is not full cover that will increase I have the 5 images right? You can give you the 5 images and they are registered one shot you have 5 but back side आता है कि नहीं देखना है
बैक साइड नहीं आएगा सर उसमें और उसमें सर इस तरीके का ही कैन सो वी हैव person sitting in front of the camera and there are 5 cameras and in one shot
all 5 you have taken
so you will take 5 images of the same person.
Okay.
Then
but can you let us think of this 5 let him do this one he has to do only the arithmetic
whatever I mean whatever 3-dimensional information you get
then what we can give you 30 degree 15 degree 0 degree minus 15 degree minus 30 degree images
Okay.
2D images can you combine them to get the 3D
also they are registered so it
Registered also.
sitting and 5 images 5 cameras are placed and it's not changing so from the same view when you are getting the same person and he is not moved also
simultaneously 5
simultaneously they are
photographs
taken so they are registered so it's good for you they are registered.
Okay, I'll do that.
huh?
I'll do that.
you are changing so you collect the data so who is next
So this is the reference paper face congruency induced local features for finger knuckle print recognition. Basically the steps involved in any biometric recognitions are image acquisition, ROI extraction, feature extraction and matching. And I will be doing feature extraction and matching for finger knuckle print recognition. I will be given the region of interest images. I have received it. My problem statement consists of 2 parts. The first part is that I have to implement the technique that is suggested in this paper and I have to report the equal error rate. This technique is known as local feature integration technique. In this LFI scheme, they essentially extracts the 3 local features out of the image and find their individual matching distance. These 3 local features are face congruency, local orientation and local face. And after extracting these 3 individual matching distances, they combine them to get a final matching distance. This is the ER rate which they have given. So obviously the combined will give better results than individuals. The second problem part is that in one of the previous papers they proposed a local global information combination scheme in which they combined a global feature and a local orientation feature, and they received the ER rate of 0.402%, which was quite good. So in this paper they are proposing that we can combine the two other local features which we calculated and integrate it in the above scheme.
So this is actually the state of the art 0.3, and the paper that he is quoting, that is the latest state of the art.
So sir, detailed approach I'm coming with. So first part involves extracting the three local features and calculating their matching distances. Second part will include extracting the global feature, which is the Fourier transformation coefficient. Okay, so first part, the basic idea of phase congruency is that they have used is that the features are perceived at the points in an image where Fourier components of the image are maximally in phase. These points are said to have high phase congruency. To calculate the phase congruency, they have used Peter-Kovessy's algorithm, and Peter-Kovessy's basically used this equation. Okay. This equation comes from the result that the local energy function is directly proportional to phase congruency. So whenever there will be a peak in local energy, there will be a peak in phase congruency. These A's are the amplitudes, J is the orientation, and they have used the sum of amplitudes on all scales, approximately. The first step would be to calculate phase congruency would be convolve the image with even and odd symmetric filters. In this case I have used log Gabor filters. So the result of this convolution would be E and O. These are even result and odd result. So to calculate phase congruency we need local energy and amplitudes. To calculate amplitude they have given this equation. To calculate
No, that's okay. It's very difficult if you tell all this.
yes,
Right?
yes.
I need to know from you all these things later on. But at this moment you tell us where you are.
So I have implemented both the codes.
What is the step?
So I have to test it. I have not calculated EER. I have to calculate EER right now.
Because here in the 0.85,
It's basically different fusions, so
Mm.
it's,
It will take
for
generally-
different things, and then you will be.
it should be less than 0.6.
No, the 0.35 is the expected.
But that is the thing they have coded. So whatever he has coded, it will be giving something like 0.35. But you want, I know that.
So
So
that is the thing. You have written code and whether code is correct or not, those two will come out to test.
for testing, I'll tell you have got the data.
Yes, sir.
Also the script to generate the result I have uploaded on the web page, the term paper project web page. You can download from there, and there is a readme file you can read, and then you will be knowing that how you can use that. And I'll tell you that how you go with me after how to test that.
As you remember, my name is and my multimodal biometric project title is finger knuckle quality parameter. Actually, I have not given my first presentation, so I would like to go from the start. First, telling about finger knuckle print. This is the finger knuckle quality parameters. My problem statement was to generate a score from the quality parameter. It should be consistent with the visual, and these are some basic parameters. And then using those quality parameters, I have to generate a normalized score, which can be used for finger knuckle recognition. And my adopted, as the finger knuckle system is a new system, so there is not much research in the field. So I have my adaptive approach is like I have studied various other biometric identifiers quality estimation, like iris and finger, and then their parameters I am trying to manipulate them according to the FKP and then applying them to.
So you are considering the four parameters.
No, those four were the basic parameters.
Four basic parameters.
And
Now,
other-
after that will be defined.
I will be defining. So till now I have implemented this edges detected Kenny algorithm, and for these images, matlab, these mean values I got.
What is this?
Matlab, these are different RI section of the images, and the
The mean value of what?
mean value of the pixels, the whole pixel give me these images,
Mean value is 0.151.
and these images I get from the
KV.
So-
And after that,
the point the I can manipulate the values to get higher, but for this white the one bit will be given. So the mean would be
these values are what? 0 and 1?
Yeah.
0 or 255?
0 and 1,
0 and 1.
and
So the number is lying between 0 and 1.
yes,
That divided how many ones divided by total number of.
total number of pixels. They are
So that value is 0.1.
0.15 for these images.
Okay. So what it means? What is the use of this?
This value can the more the number of edges, these edges, the more number of edges, it would be possible to use for recognition.
He's trying to say that if you are having
Good edges
good
and
amount of edges,
good amount of edges, then it
Number,
can
good amount of number of edges. Good number of edges.
good number of edges,
then
it
it
is
can
more
be
discriminative, hence the quality is better than. So as you were suggesting that 0.15 it is having prominent edges and
Prominent
0.11 it is not having that prominent edges. That's why the
yes. Here there is a little specular reflection due to which there is less number of edges, and I can use other edge detection algorithm to improve these detection. And as I showed that their specular reflection is also coming in the image, so I tried a specular reflection algorithm on this. This image has having a large area of specular reflection, so it's giving a very low score. Here there is very less amount, only little here, so it's giving a higher score. So this and the previous both are, the image are in the same sequence, so we can see that both are consistent. So we can use both together, use a normalized code giving more weightage to the edge part to get a desired. One other, I applied the focus one I applied, but I didn't get good results. But
on focus you applied again on pressure. There someone has suggested.
that's what I thought. I have to apply it on some little part.
Yes. On different package, then you
Matlab,
find
the
out
focus is-
block, right?
Yeah, focus also works like it also gives me the good number of edges. Matlab, the more the edges, the focus value would be more.
Okay. But why not entropy you take care there?
Yes.
That will give you also energy factor.
I am searching more.
Entropy is one thing, right?
I am searching for more. Entropy, yes.
Minus summation R log or some formula like R by log R. Something like that. That value will give you the energy factor. So energy is important factor.
Energy of the edge map, or if you try to find out the energy of the edge map, basically that can be used.
So entropy is look for. Entropy is one possible.
Entropy and one more point Aditya told me, I was quoting on it but I haven't done, like the joint between the edges, there are more edges, there is like minutia points. So
Number of bipartition.
number of minutia points. So those can be also detected and
Don't go for the termination point because since you are abruptly taking the images, only bifurcation, trifurcation, those type of things,
okay.
not the end point.
But the image is not, I didn't understand that exactly.
You see the image,
Yes,
there are, beside that there are bifurcations
yes,
or crossing in there.
yes, yes.
Those type of points.
Okay.
Don't take the end point. End point because these images are cropped. So end point doesn't have to be.
That's the region of interest for the top.
Or what you can do is that for endpoints you leave the within a particular within the
Take a cross section of that.
10 pixels up and down, left and right. You leave that and then work the inner.
Then it's possible.
And these are the rating works I have done. I have read about the PolyU database and the paperwork from Lin Zhang, who first started this finger knuckle quality estimation, and other paper provided by Aditya Pawar.
I'm doing project on biometrics template security, and basically template and feature extraction working areas.
What is that?
Basically in a biometric system, biometrics template and feature extraction. I'm working on this to process this.
We just wanted to show that these are my areas.
What are the things you want to do first?
I'm working on templates.
What is your portfolio?
For template security.
What is the input? What is the input?
Input will be
Fingerprint. And after that,
censored in ROI.
ROI also you will do.
No. I'm doing just on these feature
This
extraction.
one, on this, with this. Feature extraction you will do it.
Yes, some modifications.
Huh? Okay. You will do the feature extraction from the fingerprint, and then you will be creating the template picture, right? Okay, follow.
So I'm using BioHash.
What is virus?
So it's a method basically by using hashing to basically convert the normal template, the normal feature template, and by
Whole system, the name of
Basically,
the system is BioHash.
name is BioHash.
Explain the system. Yes.
Basically, in that I'll take a random vector, and I will by using the Gram-Schmidt process, I will change it to orthonormal vector. Then I will take the dot product with the correct feature template. Then I will store it in as 1 0.
I'm not getting.
Basically, I will use this random vector initially, and I will by using this Gram-Schmidt process, I'll
What
change
is
it
Gram?
to change any vector in the orthogonal vector. Then then I will multiply the node template, which I will get it from the feature.
Template is what?
Feature template.
What is that?
I'm explaining.
You will be getting some template. Is it also vector or matrix?
It's a vector.
It's a vector. And also that your random number is also vector.
Yes.
Right? If you multiply these two, what you will get?
It's a orthogonal vector. Then
It will be a vector.
yes. Then by using the threshold, I will get
You will get what? You will be getting
binary. This is
binary
binary
what?
scale.
Huh?
0 1.
It's a vector.
No, it's just
Hash.
I mean, I will store it in a array.
It's a protected template,
Template.
and which cannot be used
While
to construct the original biometric image. This is the kind of template.
No, but once you put the inner product, what will be the output number?
Yes.
Am I right?
Yes.
And
The-
what is
The concept here is the token, the random tokenized random number can be changed in case anybody knows that his biometric template has been compromised.
see inner product of inner product of the random number with the template. It will give you what is number.
yes,
Am I right?
yes.
Then what is this box he has drawn
This
above? What
these
is
are
it?
the
What
basically
is this?
images. I mean, from this.
What is
No,
this?
sorry. These are
You
the
have to show it to the
vector.
vector.
Yes.
Template is a vector.
I am not finding. I am thinking that these are from the noise.
No.
Multiply. What is no? This is
It's-
the image you are showing. This is an image and this is another image. This is a noise image you are doing. And
Okay, it's just a vector.
Actually, so biometric sampling means adding some kind of noise at some known places.
but noise is it, but it's a vector.
Yeah.
Yeah.
But this represent is not vector. Then image. Why not image multiplied with noise and that something like that I was thinking.
It's just a vector.
And image is defending you like anything.
Yeah, I got this capabilities.
Right? Till then you were safe.
No, actually I was trying to.
Why
I was
did you
not
do it?
sure.
Not sure what type of problem. Not sure what type of problem you will be solving.
Yes, actually I was working on palm system.
Okay.
So according to this, from the threshold I will write this.
See, you will be getting some number.
Yes.
After that number,
So
that will be has. This is an integer number.
which?
This niche.
Yes.
This is an integer number or
It's just basically it's a template of 1 and 0 binary
so
numbers.
it is an what? Integer or
Integer, it's an array or maybe
array of what?
of these values.
Binary.
Binary.
So it is a basically hashing में क्या करो? उसको चॉप या आगे जाओ.
So
hashing में क्या करो?
this is the yeah, okay. So this is for the basically template part,
ठीक है.
and now I'll use in the feature X,
ये सब छोड़ो, ये सब नहीं चाहिए. तो आपको भी काम देगा.
and I'll use the for this Fourier Manual transform
For what?
for feature extraction.
चलो feature extraction. What
And
feature you will be extracting?
Basically this initially the basically the frequencies, the variation in the frequencies, the horizontal and vertical and diagonal, and that is the basically approximation image. So after few levels, after 2 levels, this is the example, and
Basically, you have reduced the size.
yes,
Then you got a
reduce.
0-1 matrix. 0-1 vector.
Yes.
Huh?
Yes.
Okay. Some of them will be positive, some of them will be negative, so you will get the 0 vector. ठीक है? उसके बाद
Actually, I will get the 0 the process. This is the process.
ठीक है. उसके बाद
Then I will forward it to the basically
to the
next.
inner product thing.
Yes.
Okay.
So this is code.
But after that you get some number, a vector.
Yes.
After that what? That will be your template.
Yes, template.
That will be secure
Yes.
template 0101 like that.
Yes.
And
So
there is no concept of Manisha point,
no.
right?
Yes. This process is better than the Manish.
How do you?
According to
But standard does not allow.
ISO
ISO 19794 tells us that you have to use Manisha point. Anyway, let us see. Let us see.
paper. So this
I
was
understand that you will be taking the 3 components and then you will be writing a
vector by reducing the
and that side from there you will be taking one random number. Instead of doing a random number, you could have taken some other thing also, some other biometrics also. Why not IDs or some other data?
iris or then yes, this can be used on face,
Fusion
iris.
of these two
Yes.
to get another. Why not?
Actually, the initial paper he is implementing for that. And we
It's-
can test on that when the results are there.
So in that case, I can have one feature vector, which is the fusion of IDs and
IDs and
two of them.
Yes.
That will be the better. But can you finish it by next week? I don't know.
By so.
To generate a biometric key and define a function for the biometric key. So for this I have read the following papers on basically on palm print verification, principal line extraction and generating the key. So the main problem, one of the papers is a palm print verification system from 1D DCT feature, that is of Mr. Badrinath, who has worked here. the main problem with using that approach is that we need to have certain set of features which are generated each time we get the palm print. So we cannot use Hamming distance as such for a particular threshold. We need to extract some prominent feature which are generated every time. So for that we have decided to use the principal lines, the head line, the hurt line and the life line to basically consider as the feature vector. In order to extract the principal lines, I am using the implementation of the first and the third paper. In the third paper, I am using the enhancement code of that enhancement part to enhance the image, and in the first, I am using the consecutive filtering operations to get the result. So this is the ROI of the image that is provided to me. From that, the enhanced image looks something like that. There is some problem with the blocks that I need to still clear from that. From the enhanced image, a smoothing filter is applied to the image and to basically remove the noise. Then I have applied sober filter to get the edges and get the main lines. From the sober filter, now there can be cases in which there are lines, there is a principal line, yeah. So, but they are a little bit separated. So, yeah, yeah. So that for that I have used closing and further smoothing to get the image. And let's say there is a principal line of this kind. So this is the palm, and the principal line is such that there is just a very little gap between the principal line. It's not exactly touching, but by filling it, yeah, so kind of, so yeah, so for that I have used the STRL disk object, so to fill that. So from that, this image is generated. Now we basically merge the gradient image that was obtained from the Sobel filter and this image, the closed image, to get this particular image. Now in this particular image, there is clear separation between the background and the object, so that will help in binarization of the image. Now we use the automatic threshold to get the binarization of the image, and each of from this we get the connected components of the image. From the connected component, we find all the connected components and apply a threshold. Now the threshold is dependent on the biggest connected component. The threshold is
basically on length.
Yeah, not exactly on the number of points.
And that is the length of the connected.
Maybe the width also, as in instead of the principal line, there are wrinkles or some other lines which are very thin but may be long. So we need to consider the total number of points instead of the total number of points. Total number of points will take into account the thickness as well as the length.
Not necessarily, but length would be a good idea.
But there could be there are lines as in which goes from. There are lines which are very long, but yeah. So the number of pixels are considered, and
Basically, you want to know the density of the
yes, sir. Yes, sir.
If density is high, then you can this.
Yes, sir.
Right.
Yes, sir. So this is at lower threshold. This line is actually a wrinkle that we are getting as the principal line, but at higher threshold we are not getting this line. So the result, yeah. So the threshold is on the basis of
Number of points that you got in that connected component.
yeah. So in the biggest connected component, so I find the largest, the connected component in which there is the maximum number of points. So using that, the threshold is decided. So the result that I got was, in this image, I got the 3 principal lines. This is the enhanced image and this is the result. This is from the KCR database, one of the images from the KCR database.
You have coded up to this?
Yes, sir.
These
These are mine image.
the pixel, as you are saying, it is having, it is a connected component having some X number of pixels. And after that you have increased the threshold. Then you are not getting this pixel.
Yeah.
But still you are getting that line.
Yeah, actually.
Because I feel that that small line.
Even this line shouldn't have been there. So this is the problem with the enhancement there. The enhancement makes the image dark. As in the next image also, you can see due to the enhancement here the more number of pixels are black. So as a result of that, we are getting some pixels here. So I need to improve upon this to basically improve on this. So this is one of the image from the PolyU database. Here these lines are very thick, so this is much more spread.
Okay, how many lines you have on your phone?
So
4 lines.
kind of we should ideally get 4 lines.
See, go to the previous slide where you have go back. See, here also you have the 4th line, but you don't get here because that is not connected. This 4th line is there.
This one.
Because your line fitting is there. It should have been joined. As a result, you have missed that.
Okay.
You understood?
Yes, sir.
So there is something is missing. You watch out video.
This, as the paper said, this algorithm is not that accurate, but it is very fast. So we are trying to also implement other. Okay.
Once you distribute, then go for the. Okay,
So, like there are some results in which the results are very bad. So, in this case, as for example, using this algorithm. So we are looking at other paper. Using one of the paper uses radon filter, modified finite radon filter transformation to get the this principal lines, and so I am trying to basically I am reading that and trying to implement that also.
What is the purpose? What you are doing? You are trying to find out this principal line.
And then from the principal lines, because the principal lines are prominent feature, they will be generated each time. So when we generate the key from the principal lines, in the key we consider all the points. So if in the key there are too many points which which does not appear the next time, then if a person gives a palm print, he won't be able to again generate the same key the next time if there are too many such points.
Means that the lines that you are getting, it is you suppose you assume that every time you will be getting those lines.
Yeah, I should
from
be
the
getting.
same palm.
Yes, sir.
If it is not, then whole system breaks down.
Yeah, kind of. So
So this enhancement is because behavior of enhancement is a bit different. It will change the image. If you see that
Yes.
here you will be getting, because it introduces artifacts. Several artifacts are there in the image, this enhanced image. So next time when you are getting the same image, you may not be getting the same artifact again. Enhancement, if you see two enhanced images of same palm print, you will see several features which are here but actually are not in the image. You have introduced that, as you are saying, what you have seen. Maybe in the next image you may not be, it is because of the light area or some image or something like that. So if you want that level of accuracy, because after all these are the points which you will be using to create the key or whatever. So
Yes,
and if it is changed, then the whole thing will be, the accuracy is very important in your case. Otherwise,
so even in the enhanced image we need to extract the principal lines very accurately.
what I
And-
feel is because for our case we got if we are recognizing the thing, then we say that okay, it's not exact match.
Yes,
But
sir.
for your case, it's not like this.
But here onwards, you have to do locality sensitive hashing, so that and the enhancement should also be, as you are saying, enhancement should also be so rigorous that it produces the same kind of key. This is only the initial step that we are doing. This kind of
What
system.
do you expect? What do you expect from
Yeah, I expect that the locality sensitive hashing is applied over that, and then over this figure, after getting this principal lines, we would have
So first job is that you have to extract
extract the principal line. Then
So first, has he done it? No, not yet. What he's telling, he wants to meet the improvement of this so that he can get. So say, let him do up to this. Right? Let him do this feature extraction. Right? Only four lines correctly. Up to this let him do, and then you take out of heavy for him because you have to understand that itself. So you just extract the four principal lines correct.
Okay, sir.
Because you have to tell us why it is correctly what you have to justify. How much it is correct.
Okay.
Again, the accuracy of detecting the principal lines should be mentioned here. That 80% correct. Say, as I have shown you the
Yes,
previous
sir.
one, that this line you just why you missed that?
Yes, sir.
Because there is a high probability of missing because here there is a C, here is a some it is inside.
Yeah, so
And
more
the
in
light
light is-
the creating problem. So you have to threshold, whatever threshold you are using the bottom of that side, you cannot use there.
okay.
It will be different.
Okay, sir.
Understand?
Yes, sir.
Accuracy is a key issue. And the second thing, that once you got these lines, how you show in your presentation, you show on the image, you superimpose this thing.
It is matching on.
Okay.
Yes, matching on it. You'll see that with red color or some different color, you superimpose and then show that here it is matching, here it is not matching. Why this is matching, why it's not matching, you have to justify it.
That will take care. That is up to the C.
Okay.
It's just you superimpose only. Color, put it, and then it will look like it is matched, and you can prove that it's matched.
Okay.
Right?
Yes, sir.
So, but this one you have to see. What it cannot be a fixed threshold. It should be a dynamic threshold.
Yes, sir.
Clear?
Yes, sir.
Good evening, everyone. My name is Adarsh Kishan. I am working on fingerprint-based fuzzy vault system. My problem statement is something like this. There is a paper that came out recently in 2009 that claims a very high accuracy rate of about 98%. What it does is it uses a composite feature based miniature mapping and uses a hierarchical structure check to do matching. And what I'm thinking of doing is like do implementation of this paper and checking its accuracy claim. Also, will be looking at on the scopes of improvement in this paper. Basically, if we talk about fuzzy vault encryption, it can be just broken down into two steps. First step is encoding, and then is decoding. Encoding comprising of registering a genuine user, and decoding phase is simply when a user comes, give its identity, and the secret gets revealed. So what happens in a simple encoding phase is that we have a secret key that we have to protect. So what we do, we take a secret key S, we add some error correction bits to the code, and then from this error correction code, composite key, we generate a polynomial. And to this polynomial, we use the given fingerprint template. Using these miniature points of the fingerprint, we use a hash function to get a single point, and these feedback these points into the polynomial to get the value of that polynomial on that particular x value. So these are the genuine points in the system. To these genuine points, we add some chef points. Chef points are like the fake points in the system. These are these offset points that make the system secure. So, and then we take a union of all the points and then scramble these points and then make our vault. In the decoding phase, what we have is a set of points in the vault that includes both the genuine and fake points, and there is a query in miniature that arrives. These candidate points try to identify the genuine points in the set. Since they are fake points, there are fake points we have introduced in the system. The query has to identify certain number of genuine points out of to reconstruct the polynomial. Since if we have initially made an n degree polynomial and we can remake n plus 1 n1 values of the polynomial, we can guess the polynomial. We can, after guessing the polynomial, we can check its check it if it's right or wrong using the CRC code that we have appended after that. The problem with all these initial implementations of fuzzy vault was that it uses a pre-aligned feature, pre-aligned fingerprint impression that uses simple miniature encoding with with simple x, y, and theta value. The simple this pre-alignment and image registration is a non-trivial issue, and also they are storing the alignment information in terms of x, y, theta is inherently insecure. So what the paper has suggested is to store this miniature information in a composite form. So, for example, this is a miniature point mi and mj. What we will store is the length between these two vectors, the angle between these miniatures, and this angle between the line connecting the origin and the second minima and the initial point. So what we actually store is a composite vector. There is a central miniature point, and there are some several miniature points that are in the neighbor. So if we have a graph of miniature points, what we do, we take a central miniature point and just consider the neighboring elements of this miniature to make a composite feature vector at this point. Oh, no, so we have x, y, theta values for each of the miniature. So what we can do is we have x, y, x1, y2, and theta2 value of all these things. So we can easily find the distance. We make the feature vector for all the miniatures in the system.
How to get the this is center?
No, we take for every miniature we do this.
Every miniature you will be finding the distance.
Okay.
You got the distance. Then
For every miniature, I make the composite feature vector.
NC2.
Yeah, NC2. This is the encoding phase, the new algorithm that uses. What it does is we have an initial key of 144 bytes, and then it includes a 16-bit of error correction code, and then that results into 160 bit of a key. Then we divide into 10 fragments and construct a 9-degree polynomial out of it. And then we have a when we register the user, we take out 38 top 38 composite vectors out of it. We feed these composite vectors into the hash function, and then via the polynomial, and then we introduce the chef points. See, we make the composite. It would be better if I explain with the image. Okay, so that's fine. So if we have the initial registration image, we obtain several of these points. So
distances.
No, if there are n miniatures, there would be n such points.
n multiplied by
No.
For each getting NC.
No, the value corresponds the correlate. What was that? The vector that we are making, that would be n vectors only.
Okay. N minus 1.
Just take a concrete example. For example, this is A, B, C. For example, this is just E. So each one would have a vector. For example, if we are only considering the elements of this level. So
This circle you are drawing, that is the thing. How are you getting this circle?
we will take a threshold value of the number of neighbors we have to consider.
And if that minutia point is missing next time, minutia point is
This is while the registration. I will go to the next phase while time.
so is the ratio, whatever minutia points you got, for that you will be making the circle.
Circle and considering.
Circle is based on some threshold. Okay.
So we will get 5 of these points. So 5 of these. These this type of circle. So each of these circle will have this type of vector that would represent an edge. That would be distance and the angle and the relative angle between them. Using each of these pair, the triplet would be fed through a hash function, and then via polynomial to generate a point, and then we will add the chef point to create a subvault. Since we have 5 of these subvaults, we will take a union of these subvault to finally get back to the decoding phase. There's another interesting idea that was proposed in this paper. For example, this is a template image and this is a test image. In most of the cases, what happens is the overlapping region between these two are very limited. So what it tries to do is take the test image, segment it into various sections, like at the top left, and then use only one section of this image as a query. And if any of these section matches, then it says the user passes. So in the decoding phase, what we do is we take a local set of image, then we obtain the composite vector of that image, and then use a hierarchical structure check. Let me explain this. For example, this is the template. This is the test. This is the template vector that we have stored, and this is the reference vector test vector that we get. So what we do is we try to match the number of points, match these corresponding edges of this. If we gave the threshold for each of the 3 triplets, that what would be the threshold for individual one, and then we try to match it. In this case, if we get a match of 4 edges, then we go into next step. That's we mark it as conditionally mapped, and then we try to match the neighbors of it. For example, we will consider this neighbor and consider a feature vector for this vector, and repeat this step. If they are threshold defined at each of the step, and if it satisfy all the step, then we will obtain the key for that particular value. And if we can get 11 or more than 11 keys, then we can reconstruct the initial polynomial, and then verify the correctness of the polynomial using the CRC kit. So what I'm thinking of doing is take the miniature pointer xy theta value and just get the composite vector out of it, and then using this I will generate a random key, and then store it in a vault, and then try to feed it with false users and try to say the security of the system. These are some of the literature. I'm trying to skip over this. I've coded most of the encoding part of it, and just the testing part of the encoding is left.
What about the decoding?
It's left. I will come.
Testing of the other step is
The encoding. I've done the encoding part. We're still searching for the data set that the paper is using.
we do need the others.
Our data set. Because actually, the result has been shown on the FTC resolution. That database we should.
So I want to verify the results of this.
Also, the standard way is just to find out what is the actual accuracy of the system. In case we do so.
Are you going to get the data set?
I think it's FTC resolution is available in all research. So on the phone we have.
All is available. Something is available.
Only sampling is
No, you have to pay money.
it is available in the book of that.
No, you have to pay.
The CD also.
It is written that it comes with the CD.
Then go.
You can do without database, but
Your database, some database you need.
we that we have.
My paper was same as Adarsh one. The difference now,
Others one.
Adarsh, the previous same.
Others.
Yes. So, Adarsh missed some of the points. I would like to further enhance it.
No, sir. The problem is actually different. The basic idea from the starting, some points are same.
Okay. So,
He want to work on the cancelling parameters and he is generating the keys.
so till the encoding phase it's same. So in the encoding phase, the algorithm is actually hierarchical structure algorithm. So hierarchical structure algorithm, the advantage is that as Raj told that for any points, so d is the distance and there is a feature set d, theta and phi. So how do we, there is a threshold, okay, so there is a threshold between what is the maximum variation it can take. So the hierarchy terms comes in, first we check for this and then we check for its neighbors. So this is where the hierarchy terms comes in. So if say 10 points passed for the first feature set, there. So if I do this, so this is still say 10. These are 10 points. So say a threshold is like say 8, like 80%. So if 80% of them are matched, then it is so like so there is a threshold of delta d, delta theta, and delta phi. So when we compare 2, 1, d something else. So when we compare both these minutiae points, so if 8 points are met, then we say it is done. So then we go further. Then we match for the neighbors. All these are the neighbors actually. These are the neighbors of this point. So then we do for the neighbors. And when we do for the neighbors, again some will match and some won't. So we will subtract that then, and sigma is equal to q by k, where q is the number of matched neighbors and k is total number of neighbors. So this is, so sigma greater than certain threshold, we declare it. All right. So this was the encoding phase. So next step, when we what we differ is mine would be to make it non-invertible. So I am still looking onto this part. I have not implemented anything yet after the encoding phase.
But this is the important thing. Remember that, see, you have started with the idea that you will be doing similar to cancellable biometrics, which is non-invertible.
Yes, sir.
Right? So unless you get the non-invertible component,
Yes, we have.
be careful.
Yes, we have to think on the matching algorithm.
As in, it is quite important for a multimodal biometric system because since it involves many biometric traits, we might have to give some weights to each biometric system, each biometric trait in order to how much this is important or how much that is important. For that, the quality is actually very essential. I would be identifying some parameters and quantizing them that affect the image quality and further the recognition. And finally, I would be fusing the quality measures for each parameter into a quality score or quality levels. So the process is basically I would take the input image, the iris segmentation would be done, and then the iris would be normalized, and then
the important part of my project would be the finding the quality measures, and then I would use the source of each quality measure to give a single quality score.
Your input is the IDs normalized image.
Yes.
You do these three factors, right?
Actually, sir, in the beginning I started reading iris segmentation and
Please, why do you need that?
uh,
They are all available.
yes, sir.
Only your work is iris quality. Iris quality is there.
So actually, what happens is when you segment the iris, like for example, the present method that we are using is transform and Dominant integral differential operator. That gives an accuracy of 50%, as in
Whatever it is.
and there
So
are,
your quality is here or there?
so basically, if the iris is not correctly segmented, then the normalized image would not be correct, and hence but it is not the important case.
Where are you going to use your module quality measure?
As
After
in-
segmentation?
So after normalization.
After. So input is normalized one,
Yes, sir.
right?
Yes, sir.
So you follow it. Why you are thinking about those things? I will give you the normalized image. Then Aditya will give you normalized image. You take the normalized input. Take this. You have to give me the what is the scope, and you have to justify why this is done. Right? That is the thing I need. We need. I don't need to see your segmentation code, IDs, normalization. Those things I don't need. They are fairly standard now at our time.
So the quality attributes are actually of two types, univariate and bivariate. The most of research that has been done in this field are considering univariate measures. Basically, the univariate measures assess the quality of the target image without any use of any reference image, whereas bivariate would refer to some image and derive some measures from that. So the attributes that I am proposing are for univariate, focus, motion blur, dilation, occlusion, illumination, specular reflection, and off angle is the new one here that I am introducing, and there are three new bivariate measures that I am proposing: correlation, luminance, and contrast.
Which one is you?
Here he is thinking to do the things in bivariate with respect to some good quality images and things.
Is it
Yes, sir. Yes, sir.
those two
I'll come to that
Yeah.
later. The thing is, in bivariate, I would consider some idealized.
Okay, one very good data you take and weight the other you take.
Yes, sir.
Are you going to consider that one only? Are you going-
No, sir. I'll take a course of these which have already been implemented so that the results can be compared. And off angle is something that has not been done.
Yeah. Morning, you did not attend morning class.
No, actually, sir,
Did you attend morning class?
I did, sir. He actually proposed it as well as the basic ethic thesis.
No, that's okay, but did you attend morning
Yes,
class?
sir. Yes, sir.
So he presented offender.
Yes, sir.
Is it you or me or he has done it?
Sir, we independently thought of it and we are using
Independently thinking नहीं होता है.
Sir,
Sir, still, sir, I feel that both should do because I am not sure that he will do or he
Sir,
will
I
be able to do. So
think
if
when
anyone
he is
do,
using his
it's fine,
computer,
because hopping in
it's
is the tricky thing and
No, then I agree. But what is the credit I will give to one?
but whoever is getting the better
Why?
marks.
There is no problem.
So actually we both are using different
Whatever it is, I will give the credit of one person. You fight it, both of you fight together and then tell me somewhere. But I want to see all this.
yes.
So,
I think this is the off-angle approach. Basically, the off-angle thing is this, as in when the image of the iris is captured, a person might not be looking straight into the camera. He might be looking upwards or rightwards or leftwards. So basically, what happens is there is some reflection on the iris, which reduces the quality of the iris normalized image, and this can be measured using two methods. One is we can detect the pupil and then draw a boundary box around it and measure the major axis and minor axis and take the ratio of its E by A. This would actually correspond to the degree of off angle. And the second approach that I am interested in is it is a little bit different and a bit logical. As in, if you see the specular reflection there on the pupil, this is the concept that I would be using. As in, if I do not look towards the camera, I look somewhere else, these reflections are bound to come on the irises. So my measure would be, I would consider the distance between the center of the pupil to this point, to the specular reflection, and this can be normalized by having by dividing the radius of the pupil with the distance from the center of the pupil to the specular reflection.
And his assumption is that if person is looking to the camera, then basically it is the specular reflection which is telling where he is looking, right?
Yes. And moreover, sir, in the first case, there is also one problem. We assume that the pupil and the iris are perfectly circular, which is not true. Actually, it might be elliptical in some cases, and when it is off angle, it is already an ellipse. So, and we consider that it is a circle.
By default, I think B by A would be on major axis and minor axis. So he's assuming that it is.
No, sir. One case is of on angle, and the other case is off angle. If I view a circle sideways, it would appear to be an eclipse to me. So if let's have it on a two-dimensional plane, and when I measure that, it would look to be an eclipse to me. And when I measure its major axis and minor axis, that would give me the degree of off angle. And so in this basic approach, I assume that originally it is a circle in on angle, which is not true. So this might be giving some good results, which I would like to check, but theoretically it has some flaws in it. So I would be, first of all, my first choice for the approach would be this one. See, many times we have occlusions in the iris images where we do not get the upper part of the iris. So when this is normalized, we have the top right corner which lies around here as in. We have the top right corner that is free of any occlusions. So we take this part, and what we do is we convol this image with a 6x6 kernel. The kernel would be same as Anvesh, and I would take the values of this kernel and take the mean of the pixels, and this would be my focus measure. And there is another approach to this. This was in a paper by N.D. Kalka. What he did was, he took two patches on the iris, and then what he did was, he had two thresholds, a low threshold and a high threshold, based on which whosoever pixels were actually in between those thresholds were called correct, and the others were defective. So the patch which had the less number of defective pixels was taken, and it was converted to the 5x5 kernel. And then the mean value was taken, and this would be the focus degree. This is expected to be free of symmetries in the images. Now I come to dilation. Dilation is basically the aperture. Of the view.
Sir, he is saying that as he said in the previous one, he said that if we use only on the patches, then it will perform better. So I have said that yes, if you want to do, then you can do, and just we see that if you got some improvement or not. For dilation, I think is exactly the same. You are modifying it, or
Dilation is exactly the same.
The things which are exactly same that are not required. As I have said that.
Very but don't fall.
Yes, sir.
You'll be using that point.
So the occlusion it is the same.
Very white.
Okay, sir. Yeah. And the contrast in this is also same. Yes, sir. Yes, sir. So what I plan to do is I will express the image in a single dimensional array, just a matter of convention. I'll have basically first of all I'll discuss a case of two images and the inspiration from where I got the idea. Actually, the idea was well, if I have an image and let's say it gets distorted or some way in some way, then how do I consider that it is the same or not? As in what parameters? So there comes in correlation, luminance, and correlation, luminance, and contrast. So what I do is I calculate the standard deviations and the means of each and every image, and then using these measures.
But these two images,
Yes,
you want to obtain sigma xy,
yes,
then they should be registered. These two images should be registered. Registered. Otherwise, how can you get the correlation parameter?
As in, sir,
X and Y
yes, sir.
the two images,
Yes, sir.
right? Now one image like the other one is shifted.
I'm sir assuming that the dimension of both the
Dimension is okay.
would be
You
same.
draw a face ID code, some code. You draw image is just draw it. Some design will be there, no?
Yes, sir.
But next Y image is shifted,
Okay, I get it. Yes, sir.
right? Because you will be taking this whole thing.
Yes, sir.
Now, because of some reason, this is shifted.
Yes, sir.
Then correlation
The
coefficient.
correlation won't work. Then the
How are you
contrast.
going to do it?
This is contrast.
You shift your pattern. Suppose that this is the image and you wanted to find out the correlation between this.
Are you going to the best correlation?
Yes, best correlation. Try to find out the best correlation.
That I would, sir. I would first of all this is the first correlation equation. Then I would try out other correlation equations. And moreover, actually the correlation this correlation takes care of the linear relationships. As in, there might be distortions. Like let's say the figure is of the form this. Then this would be able to give the quality as well if the figure is of the form this. As in, these kind of distortion, this time anti, but yes, I agree. Further study after presenting the correlation equations.
Second point, you need not to tell. Range of the occlusion minus of A. We have to mention this.
No, as in for
They
others.
don't know what is correlation.
And moreover,
They don't know. These people, they don't know what is correlation coefficient. Yes or no?
some would not know.
Is there anybody who doesn't know what is correlation coefficient?
So this would be the luminance measure. Basically, this take is of this is the extreme, this is the y mean. So basically, as the average would actually represent the intensity of the image. So the luminance checks to that. And first of all, sir, I believe that you're confusing the idea or something. As in, I'm not matching the exact image to the exact image. I'm not considering this.
Correlation coefficient.
What I'm doing is I'm having, let's say, 1,000 or 100, whatever suits the computational complexity, ideal images. 1,000 ideal images. Then I perform this correlation test for every image. And then I take,
For every image, when the ID's code is there, no?
yes, sir. Yes, sir.
That ID's code will be, you will be finding a correlation between coefficient between the two images.
Yes, sir.
Now, in the non-ideal one, you have some code. And I have the second image, which is my test code, which is because of some reason which is shifted. Right? Now, correlation will not be there. When there is no correlation.
Again, I did not strike to me again. Let's say the number of ideal images are large. Then one image might be like in the center, or as in the code would come like this or somewhere this, and the other code might be this. Other code might be this. But what I'm assuming is if this image is ideal, as in it is closer to ideal, if this is ideal, then my database would have an image similar to this, because 1000 is a decent number.
Similar to?
As in, and
See, the above one is an ideal image.
yes,
So bottom one is not the ideal image.
yes,
You
sir.
got it?
So
That's
it would
all.
not be correlated
So
to any of my image
yeah,
in the
and then
database.
result will be zero
Yes, sir. So
or negative.
it won't be good. Yes, sir. So
But that is not the thing, right? If by shift operations I can go back to this.
sir, what I'm doing is QM1, QM2, I
Interpolation.
yes, sir. I find the correlations with all the n images where n is 1000 in that image. So if that image is close to good, then I would certainly have one of these 1000 images having a decent enough correlation with any of these images. So that is the basic idea, sir. And then I would be operating these. I can give them weights, or I can simply take the maximum that can be further scaled.
Maximum or the average, you can think of the
Average can also
Because
work.
maximum is also something that you can do, because you have good sample images. So if the good quality images should be matching with a fair good value with all of them or some of them.
See, the 5-degree rotation may be there. I am still not. The 5-degree rotation is your image iris color. Can you justify why you are telling that you get the?
If you take, first of all, if you leave the correlation part, then you come to contrast.
No. Correlation part you cannot leave. Correlation is an important parameter. That's why I'm telling.
That is
That
otherwise.
you take a block and find out the block from block here and there, then you register first, then you obtain the correlation. Something you have to do. You have to find the register of the between two image and obtain the correlation. Something. Otherwise, if you cannot find the correlation will be there. Even any ID stored with another ID stored, you will not get the negative correlation. You will get some correlation.
You can recreate the correlation between using the band limited phase only correlation. PL found, I can give you update factor, it's a small code you use that, and by that you can find out the similar area, as I saying the matching area. So two iris code,
After
you find
the
out
bench-
there, and after that you can use whatever.
Registration करके you find out the correlation. Then you will get the correlation parameter. You can. This is important parameter.
I would explore various methods for quality score fusion, and I think the priority is not correct here. The priority would be this. First, I would include more parameters like entropy and spatial resolution, which I could not find, in which I could not find good reference material, so I could not include this right now. So, and
What material entropy? What is the problem?
I think that there was I searched for some papers.
Entropy gives what? Entropy gives what?
Sir, the idea of randomization, as in the amount of randomization, it is measured.
Entropy will give idea of
Randomization. So basically, the very big idea that I got from some Wikipedia page was that once if I convert my image to a spatial frequency domain, into the spatial frequency domain, then the entropy would be useful. But as in, how can I utilize it, or that was not.
And then you go to after the what? So how many of them are having the good randomness?